Okay, this chapter, chapter 2, we will talk about equations, inequalities, and problem solving. 2.1 is simplifying algebraic expressions. Okay, a term is a number or the product of a number and variables raised to powers. The number in front of the variable is called a coefficient. For example, 7, the coefficient is 7. There is no variable. For the term 5x cubed, the coefficient is 5. The term 4xy squared, the coefficient is 4. And the term z squared, the coefficient is 1. Like terms contain the same variables raised to the same powers. You can combine like terms by adding or subtracting them. However, this is not true for unlike terms. To combine like terms, you add or subtract the numerical coefficients, then multiply the result by the common variable factors. Examples of combining like terms. 6x squared plus 7x squared can be combined into 13x squared. 19xy minus 30xy can be combined into negative 11xy. Again, the 19 minus 30 you subtract because the signs are different. So a positive 19 and a negative 30, subtracting gives you a negative 11. And 13xy squared minus 7x squared y cannot be combined because of the x, the degree is 1, and here the degree is 2. Therefore, they are not like terms and cannot be combined. These are different word phrases as algebraic expressions. Addition, these are words for sum, plus, added to, more than, increased by, or total. Subtraction can also be used for difference, minus, subtract, less than, decreased by or less. Multiplication, another word is product, times, multiply, multiplied by, of, double or triple. And division, words for division are quotient, divide, shared equally among, divided by, or divided into. Section 2.2, we will talk about the addition and multiplication properties of equality. Linear equations in one variable can be written in the form ax plus b equals c, where a, b, and c are real numbers and a cannot equal 0. Equivalent equations are equations that have the same solution. The addition property of equality. If a, b, and c are real numbers, then a equals b and a plus c equals b plus c are equivalent equations. For example, 8 plus z equals negative 8. You combine like terms, which means you add negative 8 to each side, leaving the z, the variable, to the left alone, and combining negative 8 plus negative 8 simplifies to negative 16. So your final answer is z equals negative 16. Another example, And here, example number 2. For this example, you need to use the distributive property. So you distribute 5 times 3 plus z, which is 15 plus 5z. And you also distribute the negative to the 8z plus 9, which gives you the negative 8z minus 9 equals negative 4z. Now you combine like terms on the left-hand side of the equation. So 15 minus 9 gives you 6, and 5z minus 8z gives you negative 3z equals negative 4z. Combining like terms, you add 4z to both sides of the equation, which leaves you with 6 plus z on the left-hand side equals 0. Subtract 6 from both sides, and it simplifies to z equals negative 6 as your final answer. The multiplication property of equality. If a, b, and c are real numbers and c does not equal 0, then a equals b and ac equals bc are equivalent equations. For example, negative y equals 8. You multiply both sides by negative 1, leaving you the final answer as y equals negative 8. Another example, here you have a fraction, 8 over 3x equals 6. So here you can multiply both sides by the reciprocal, which is 3 over 8, and simplifies to 18 over 8, which again is reduced to 9 over 4, or 2 1/4. Section 2.3, Solving linear equations. Solving linear equations in one variable. These are your 6 steps in solving. Let's look at an example. The equation 3 times y plus 3 over 5 equals 2y plus 6. You first multiply both sides of the equation by the denominator, which is 5. So doing that, multiplying both sides by 5 cancels this 5 in your denominator. So you're left with 3y plus 9 equals 10y plus 30. So now simplifying that, you combine like terms by subtracting 3y from both sides and subtracting 30 from both sides. You're giving you a final answer of y equals negative 3. Example number 2. Here you have no fractions, which means you just distribute the 2 times the x plus 1, which gives you the 2x plus 2 plus the 3x minus 1. Combining like terms to the right of the equation gives you 5x minus 5. Because both sides of the equation are the same, your final answer is all real numbers. Section 2.4 An Introduction to Problem Solving. Strategy for problem solving. First step, understand the problem. Read and reread the problem step by step. Choose a variable to represent the unknown. Construct a drawing whenever possible. Propose a solution and check. Second step, translate the problem into an equation. Third step, solve the equation. Fourth step, interpret the result. Check the proposed solution in the problem to see if it makes sense, and state your conclusion. Example number 1. Finding an unknown number. The product of twice a number and 3 is the same as the sum of 5 times the number and 12. Find the number. So read and reread the problem. If we let x equals the unknown number, then twice a number translates to 2x. The product of twice a number and 3 translates to 2x times 3. 5 times the number translates to 5x, and the sum of 5 times the number and 12 translates to 5x plus 12. Step number 2, your equation, 2x, which is twice a number, times, which is the product of, and 3 is the same as, which is equals, 5 times the number, which is 5x, the sum of, which is plus, and 12. 2x times 3 equals 5x plus 12. Solving the equation, 2x times 3 is 6x equals 5x plus 12. Subtract 5x from both sides of the equation, which leaves you x equals 12. Check the answer by replacing the number in the original statement of the problem. The product of twice 12 and 3 is 2 times 12 times 3, which equals 72. The sum of 5 times 12, and 12 is 5 times 12, plus 12 is 72. Therefore, we get the same results for both portions. Therefore, the answer is 12. Example number 2. A car rental agency advertised renting a Buick Century for $24.95 per day and 29 cents per mile. If you rent this car for 2 days, how many whole miles can you drive on a $100 budget? Step 1, read and reread the problem. Let's propose that we drive a total of 100 miles over the 2 days. Then we need to take twice the daily rate and add the fee for mileage to get 2 times $24.95 plus the 29 cents times 100, which equals $49.90 plus 29, which equals $48.90. This gives us an idea of how the cost is calculated, and also know that the number of miles will be greater than 100. Therefore, we let x equals the number of whole miles driven, then 0.29x is the cost for mileage driven. Translate into an equation. Our daily costs is 2 times 24.95 plus the 0.29x equals the maximum budget of $100. Now solving for x, our final answer is approximately 172.75. Interpret the results. Recall that the original statement of the problem asked for a whole number of miles. If we replace the number of miles in the problem with 173, then you will go over by 7 cents. Therefore, your final answer is 172, which makes it 99.78, which is within budget. Therefore, the final answer is 172 whole miles.